All right. Well, welcome again, everyone, to the first Enterprise One Technical Task Force for the year 2013. Glad we all made it through 2014 or 2012. Anyway, we are bringing to you Chris Papineau this month on our J.D. Edwards Performance Series. As you all know, Chris is one of our lead architects on our J.D. Edwards Performance team, and he always has great information for us. A couple of quick announcements just to get started here. We are working very hard towards the J.D. Edwards Summit, which is going to be the last week in January up in Broomfield, Colorado, so just up the road from us. Pretty exciting event as usual. It's our 4th annual one. Last time we had over 600 people come to the summit. This is a partner and Oracle only session, so it's a great way for us to get and give feedback back directly into our ecosystem. This year we have a series of workshops planned for the Monday before on January 28th. A couple of those are technical in nature, and so hope you have gotten a chance to take a look at your email and that have been spun out by me and see those workshops and try and register for them if you are available to come to town for any of those. On the technical side, we've got a user interface workshop, which will be led by Chris Walsh and Daryl Shakespeare. They promised to show off a lot of the new and exciting things that have been run through J.D. Edwards Labs in the last couple of months, including a brief preview on 913 and cool stuff we've got going for the iPad. And next workshop we've got is a performance workshop, which will be led by Gurvinder Bali and team. And then I'm going to be heading up a mobile administration workshop, which will guide you through setting up the mobile server from some interesting tips and feedback that we've gotten from a couple of our proof of concepts and early adopters that we've got for the mobile that's been released for over a year now. So that's going to be the Monday before. All those workshops are free. You just need to sign up and get into town and take part in those. You don't even have to stay for the rest of the summit, which will be Tuesday through Thursday. But of course, we do hope you stay for that. On the majority of the content that will be interesting for us, divided into tracks. There will be a tech track, an application track, an implementation track, and we've got breakout sessions for all of those on Wednesday and Thursday. So over 100 different sessions, and really there's something for everybody. So hopefully you guys can get into town and we can have a great week. So that's what we've been working on here. Again, 913 is still being baked, so we'll have some technical task force sessions on that as we can, probably starting into March. And for now, we'll go ahead and turn it over to Chris. If you can mute your phones, that'd be fantastic. I know Chris likes to take questions at the end, so queue them up on chat or just wait until the end, and you can be sure and have some Q&A time with Chris after that. So Chris, please.
Okay, thanks, Clayton. Yeah, like Clayton said, my name is Chris Papineau. I've been doing performance for about a dozen or so out of the, 18 years that I've been with JD, Orasoft, whatever we've called it, whatever year of its existence. And today's performance-related topic is about data building for performance projects. We'll get into that right after we make sure that our legal department, general counsel folks are all happy by saying this is not contractually binding information, this is not forward-looking information or anything of that nature. This is for technical guidance only. That's exactly how you should take it. All right. So what will we talk about when we talk about data building? There's our agenda. That's what things look like. Starting off, of course, with problem definition, but of course, before we get into that, starting off with an antidote, which has nothing to do with performance, or at least so it seems. The first is a question to think about, and that's that if I'm talking about getting bananas from Central America, Brazil, wherever it is, tropically that bananas come from, okay? They come from outside the United States. You've got to get them into the United States. And think about for a sec, you don't have to shout out your answer, but just kind of spin around in your head what the answer might be. How many people does it take to get bananas from Central America to a King Soopers in Denver or wherever, whatever small town USA, in the United States? How many do you think that is? What order of magnitude? What range, do you think that might be? Do you get a number in your head? All right, well, let me tell you what I say the answer is. The answer is untold millions of people, not dozens, thousands, hundreds. Well, where do you come up with that? Well, first of all, you got workers out in the fields that got to go and pick the bananas, all right? Those workers have to have shoes on their feet, okay, if they want to last very long picking the bananas, so their feet don't get whatever happens, you know, they don't step on things or whatever. Got to have shoes, right? But then somebody has to work at the plant that makes the shoes, right? Okay, so they're going to have shoes made. There's going to be boats involved. Take your pick for the bananas to get them from here to there, there to here, whatever. Somebody has to make the boats. So work for that company, right? Then once they get to the docks here, they're going to be on trucks. Somebody has to work for the company that makes the trucks, right? Both the boats and the trucks need fuel. Somebody has to go get that oil and fuel out of the ground, et cetera, et cetera. I don't know if this equine animal has been beaten to death, you know, whatever, but maybe you see my point. The point is trying to orchestrate and manage all of this, you know, is next to impossible. If one person were going to try to do it and write up a Microsoft project plan to get all these requirements together. So how does it all happen? Well, we get this thing called the free market, okay, that just does its own thing, and it just kind of happens. When a need is met, boom, it falls into place, and just all of these requirements kind of build on each other, and lo and behold, I can go to Safeway, I can get bananas, and then the next problem is trying to get my kids to eat them instead of wanting to eat granola bars for breakfast or whatever, but that's another, I digress, okay? And nor will I make any comments about, you know, the current administration's philosophy and how that differs, but I digress badly again. So the point is that it's almost impossible to manage all of this stuff manually. There's so many complexities, so many, you know, things connecting to every other thing, okay? So how does that lead in to what we're going to talk about today? Trust me, we'll get there, okay? But just think about that. Let that kind of percolate in your head a little bit. Well, we get into problem definition. Anybody that's ever sat through one of my sessions know that I'm kind of neurotic about problem definition. That if there's ever anything shows up in my queue for customer issues and it does not have a clearly defined problem definition, I will back you and say, let's have it. So, what is the issue involved? What is the case study, if you will, because we are teaching this principle via a case study. In case that isn't clear, I like to do that rather than talk, you know, ethereal up in the clouds, pie in the sky stuff. I like to take actual projects, cases, problems, and then relate that to back to general principles. And the problem in question here is an internal project on a particular UBE program, R34A705, okay? What does this UBE do? Well, it performs an exchange of data between the E1 data model and our APS, our advanced planning system, using this thing called SCABOOM, which lengthens out to supply chain business modeler, okay? Now, the advanced planning system is the legacy Numetrics code, back when J.D. Edwards purchased the company Numetrics, okay? That became our APS, or advanced planning system. So in addition to the creation of sales, purchase, and work orders in Enterprise One, this integration kind of primes the data that gets used by this other package called the Global Order Promising, GOP, no relation to the political party here in America, okay, that's just our three-letter acronym. And that integrating with the value chain, or VCP, all of these acronyms. And what happens is you get a bunch of async child UBEs that are launched by this 34A705 that transfers the data from everything you see there, all those different areas, to APS via SCABOOM, and to receive, you know, planning messages from sales, work order, procurement, etc., from APS via SCABOOM. Confused yet? Okay. Not important. This is just to give you some details on what this thing does. It's complex, okay? Planning, forecasting, whatnot, is complex. The bottom line is the output of this thing, it burps out an XML file. That is the output of all of this thing and how it twists and turns and, you know, knits all this stuff together to create an XML file that has data that then is imported into Skaboom using the Skaboom application, all right? So that is the glue between our stuff and the GOP value chain planning stuff, all right? Now, in Enterprise 1.9.1, that UBE becomes R34A100, in which case we've got new code that replaces the legacy Demetrics code, okay, and incorporates other features like the ability to process configured items. So what we want to do is the performance project itself is running both of these UBEs against 902 and 901, doing baseline performance comparison. If you see differences based on a repeatable, you know, apples to apples type of result, we report those, okay, and, you know, do analysis and whatnot. But that's not what this session is about today, believe it or not. It's nothing to do with the performance project itself. It's how we are able to get to a position where we can actually execute that project, all right? So, again, you know, this is, did we not cover anything here? How much slower or faster is the new 9.1 than the old 902? Given that we've deprecated the metrics with our code, we want to obtain clean, repeatable, validated baselines under controlled conditions, address opportunities, etc. Okay? So project execution. Okay? Well, easy. They're UBEs. You don't have to worry about complex use cases like you do with interactive apps, right? It's easy. You just run them, right? Well, kind of like, what is it, the Hertz commercial where it says not exactly, all right? These UBEs, in case you didn't get that impression from that gobbledygook description I gave you of what they do, are complex. Okay, they require a robust, realistic, and accurate data set and environment in order to get any kind of a environment similar to what a customer would use. Okay, even the data in what we call our day in the life database, which is an 80 gig database that we use for stress and trending, and that we give to partners for our benchmark, isn't even close. It doesn't even contain a fraction of the data complexity that we need for this particular esoteric app, okay? In other words, data doesn't exist anywhere, okay? So in other words, we're going to perform a valid test of all these batch programs. You've got to generate the data. Otherwise, we'll be testing nothing. We'll be running the UBE against nothing. Oh, well, runs good, looks good, you know, looks good to me. Well, the problem is it didn't do anything because there ain't any data for it to eat. There isn't any complexity behind the scenes like would exist in a real environment, okay? So it hasn't really been tested. And like Gandalf said in Lord of the Rings, I don't know if anybody's seen The Hobbit yet. Going to see it for the second time this Sunday. Very good. But it's all about testing it. So anybody that's ever seen, I think we've done for this particular group, the Performance Engineering Parable session. The recording is probably out there. And that's that if you want to estimate a rush hour drive time, say on the California 101, you can't drive at 2 a.m. Okay, even though it might be the exact same route, okay, the exact same distance, okay, from the exact same start and finish point. Everything about, you know, your drive is the same. I'm even doing it in the same car. Well, what's the problem? Look at how many variables are the same. Okay, but the problem is the time of day makes all the difference, doesn't it? Okay, you can't just say, well, it takes me 10 minutes at 2 a.m. Well, it might take you 2 hours, okay, at 5 o'clock or whatever. The same thing about if I want to get crash data on a truck, I can't take one of those Tonka trucks and crash it into the side of the house in the backyard. And my kids got a lot of those. The Tonka trucks were pretty much indestructible when I was a kid. Now they're making them out of plastic. But in any event, you need a real truck. Okay, you're not going to be able to examine this toy truck and just somehow extrapolate the data out. You need real data. Okay, you need real cars with real crash test dummies, so to speak. Okay, so how do we create those crash test dummies? That's the next section, is populating the data. Well, start with good old Systems Analysis 101, in which case you need to have discussions with people who know the app and know from a business standpoint what this thing does. In other words, you want somebody other than me for most of these, because what I know is pretty much enough to be dangerous about how these things are actually used and who would use them and why, okay? So we had discussions about data levels that should be in the database for customers, suppliers, you know, items, order types, right down to calendar, and you can see all the details, and we came up with those numbers there. You know, and those numbers, you know, are the distillation of conversations both with the developer, I think people in strategy, based on, you know, the people who know who's using this and how, okay? So based on that, you create seed data based on these numbers. You just use a few scripts, you blow out data, and you're good to go, right? And you just run the thing. Well, you know, in theory, that statement is true as far as it goes, okay, because that is what you do. But, you know, what's that statement about the devil being in the details, okay? Well, let's turn up the magnification a little bit on this business of populating data. How do you do it? Now that you've got, you know, how much data should be in there, and we've even got seed data, what do we do? Well, two primary options. One of them is you can use iterations of actual E1 applications of the correct tool and app, you know, version to build the data via normal live usage of the software. But the problem is, in order to get enough iterations and enough volume, you can't just do this manually. You can't have, you know, the monkey sitting at the keyboard going bang, bang, bang. Okay, you would need scripting and load testing tools, okay, such as Mercury Load Runner, or of course Oracle's OATS, which is, you know, what we're using now instead of the load runner tools. Again, it takes longer to populate larger amounts of data. It can be done, but the execution of the scripts can be slow. Okay, it does require knowledge of the load testing tool. These tools have learning curves on them to learn, you know, all their little subtleties and gotchas. And also, but the advantage here is that since you're using J.D. Edwards' actual code to populate the data, all formatting issues, execution of JDB triggers and whatnot will be taken care of for you. You don't have to worry about it. You don't have to worry about math numerics and decimal places and do you have enough lead space padding on business units and all the little things that can come up and bite you, all right? That's the advantage of using the code to create the data exactly as it would be created, right? You know, by users actually using the software. Now, the second way to do it is you can build SQL scripts to populate the data, okay? That requires detailed knowledge of the database, the various fields, and the formatting nuances. Now, rear their ugly head is something you've got to worry about. As far as space padding, you know, number of, you know, decimal places that would come out right on math numerics and whatnot. Since the data is being populated outside J.D. Edwards code, that's a risk. Since you don't have the JDB middleware layer, okay, that normally takes care of everything the data dictionary would want you to do and whatnot. So you don't have that. The advantage is that this is a much faster method of doing things using straight SQL. As long as you get people that are used to writing in the Wild West, okay? This is, you know, kind of the cowboy way of doing it. People who, you know, kind of damn the torpedoes, full speed ahead. I can populate this data fast, but I mean the risk is, you know, triggers, formatting, and whatnot. So there's that little, I don't know what color that is in the lower right. Being mostly colorblind myself, I think it's purple, but you see where it says important. Okay, there's about 7 or 8 of those throughout the presentation that are the general principles that I want you to go away with today. And the first here is 2 methods of creating data for performance projects. You either use J.D. Edwards apps or load testing tools and SQL scripts, and we've told you the pluses and minuses of each. So what we did is we created a data expansion spreadsheet. Information about each of about 30 tables we identified that came out of the system analysis process has its own tab in a spreadsheet. Okay. And we created seed records for each table, meaning we create one record, okay, that would be representative, you know, of that particular table. And what we would do is go ahead and loop through starting at that seed record and blow out data, based on, a certain set of rules that would be programmed into a PL SQL script. We had an Oracle person here, someone who's well versed in such things, so you can see that we were basically using a version of method 2 here, right? Is using SQL to blow out that data, mainly because we've done it before here. Okay, it's kind of one of these, I won't exactly say don't try this at home, but again, if you've got somebody who has a history, knows how these tables work, and can do it, then that's when you would do it, okay? PL SQL allows you a lot of detail in terms of looping. You can put more than just SQL. You can put logic into the scripts and whatnot. And based on these seed records, you loop through and blow out the data. Now, again, this is heavy lifting, all right? It's a complex task. What you're doing in all of this is essentially reverse engineering all the complexities of running a business. So remember our analogy about the bananas in Central America? Hopefully, the relevance is beginning to be clear here, is that we've got, an E1 database has, I don't know how many thousand tables, let's say 4,000 or 5,000 tables, something in that range. And based on the app we are trying to analyze, well, the average UBE I found accesses 80 to 100 tables in there, and including a lot you wouldn't expect that are either linked in joins, that might be in the middle of a business function somewhere, that kind of blindside you. Things, that aren't normally obvious that have to be in there, complexities behind the scene. Essentially what you're doing is you're performing a manual go-live when you're creating a set of data like this. You're getting the data in a state that everything works and everything's self-consistent, okay? Now, is there an easier way to go through this whole process of having a clean data set that you can then just run a project on? Yes, there is. I'll get to that later, okay? And I'll get to why we didn't do it that easy way as well. But back to the way, we're doing this thing is the seed data. Again, there were 30 tables involved. It's spreadsheet-based. The data wasn't precise or rigorous. And one of the problems we had is the UBE was never executed against this data in a unit test manner. We knew what the data should look like, but didn't have unit test runs to shake out problems. We kind of just went right into trying to run this thing full boat. Again, devil's always in the details. So again, another one of our important little post-its, you want to unit test that data, which can be time consuming, okay, but it saves a lot of problems down the road. Speaking of which, problems, okay, what are some of the specific things that we encountered? Well, what we had is when we thought we had every table and every piece of data and every relationship all worked out, you forget things, you miss things, because it's like trying to do the bananas thing. You forget the workers have to have shoes, right? You forget the fuel in the boat or something that should be obvious but gets lost in the complexity. They were missing UDCs. They were missing branch plant constants. There were tables that were needed that weren't populated, nor was there any knowledge of the necessity at the outset, even among the experts, on this app. Didn't have tag files. They were missing relationships. I mean, here's an example. We set up 5 branch plants with the range there given, and every one of these branch plants required a manual entry in an app called Work with Branch Plant Constants to populate the branch constants properly. Now, this wasn't in the spreadsheet. It's a simple enough thing to do, once you know that these 5 have to be set up, but it took some time to figure it out, okay, okay, this is what's missing. This is what's the cause of our problems. More examples, we had some missing tables in the initial spreadsheet. There's at least 4 there, a tag file, something like address book. The 111 is what, a phone numbers table, the calendar table, workday calendar, item price lists, all the things you can miss. Setting Julian dates in the data for work orders, sales and purchase orders, setting quantity values, for orders that are consistent, in those tables. More examples. adjusting inclusion rules to make transfer orders work, more missing UDCs, and that has to do with, you know, how we upgraded to 9.1. Synchronization between column values with work orders and those tables, those 4 tables, wasn't clear in the spreadsheet, you know, which was the result of seed data, which was erroneous. Even more examples. We had spurious data in some table that we had to go and remove with more SQL scripts that we then had to go ahead and write, okay? This one example, in the table 3493, there were records that had to be removed. They weren't a hard requirement for testing. They caused a DB driver error, okay, that turned out to be related to a tools bug we entered just to avoid the issue, okay? The table in question was a deprecated table, okay? Blah, 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 blah. All these details. We're getting really down in the weeds now, which leads us to, you know, another post-it. That is the fact that you really needed kind of an open heart surgeon's knowledge of the business functionality to work out these problems in data building. It's a complicated thing to do, to go and build this data when it's not built through the normal course of business. We made lots of spurious assumptions. There were relationships and dependencies that were more complex than we initially suspected, such as manufacturing relationships. It's not just about expanding the customers and orders. So that's an important point too, right? It isn't just about volume, it's about the proper complexity and the proper relationships between the data, even if the volumes were low, okay? It's just as important to test complexity as it is volume. So we had relationships between tables. We had 2 to 3 dozen parent-child relationships we had to work out. Things like the quantity values in 3 different tables adding up, where the quantity in table 1 equals the corresponding values in table 2 and table 3. We didn't have any idea of at the outset, but it caused inconsistencies. Work order dependencies. There are work orders that needed to be generated together since the items had to match. Purchase orders that control async UBEs on the fly, okay, which is how some needed data flew under the radar on the analysis, because we're doing static analysis, but sometimes these things don't show up till you run it, okay. Expanding data on the fly. The data is date sensitive, doesn't have a long shelf life, so you got to make sure the dates are within range of the proper range of the current date that you're testing. It took about 15 iterations to get this data correct. You know, we had, you know, 1 to 2 per day, 4 to 5 hour burn cycles each. The typical pattern looked like this. You run the job, maybe the results look good, but downstream, once you pointed a microscope at things, showed a data inconsistency. So in the best of scenarios, you'll likely to require multiple iterations to work out these problems. And also, I might add, we didn't have, you know, summer interns or whoever, you know, working on this stuff, or junior people that aren't used to what the data looks like and have that learning curve. We had people that just have some city mileage on them in terms of doing this type of project. And still we had this amount of problems, okay? So that's problems with the data. But inevitably, when you're testing the data, you uncover what? You uncover bugs. Well, we have a QA department, right? Well, yeah, but they don't test against this kind of a high, you know, octane, you know, big quality, you know, data set. They unit test data, okay? So that's why when you're doing performance projects, it steps things up to the next level as far as what you're testing against. Inevitably, it becomes a QA effort, okay, before you even get to performance. So examples, we had a PDF live issue with an earlier release of the tools code that we needed to be fixed in a later version. Apps coding issues. We had a buffer flow of a static C array in one of the business functions that was triggered by a large data set that, again, you wouldn't have seen in QA data. It would have went right through and passed right underneath the radar because it was never truly tested against bigger data, okay? To put some numbers to it, there were only 2 records in question being used in the unit testing, but 60 records were in the day in the life database, which was just the base data that we expanded things from. And again, that further shows the value of beefing up the database for performance work. More bugs. We found bugs in table conversions when upgrading to 9.1. PCs that record updates on large tables are limited to 32 gig if done in a single transaction. So we needed to go ahead and convert to the older method of committing after every update to do the 4301. So you can see all the rabbit holes and all the tangents that are getting further and further away from performance analysis. But it's just to get an environment set up, you know, that we can even do performance analysis that's even valid, okay? And again, we had our best people on this, all right? I can't emphasize that enough. So detailed data building efforts for a performance project will flush out functional QA problems. That's our post-it for this section. Next item, validation, okay? So we've been kind of doing that all along, but we didn't do enough up front at a unit test level, okay? But what we needed to do is we needed to do back-end XML file review via parsing. Even when the PDF output looks okay, it's not the PDF that's the true output of this program. What this program's purpose is spitting out an XML. So we used a tool, I think we used XML Spy, to view the data to make sure all the dependencies are there. Everything looked good. You review the logs. Again, a JDE.log should have about 20 lines in it. For most UBEs, it should say just a bunch of innocuous things, start time to stop time, a couple of other basic things. If you see errors or other things in there, you've got to explain those or fix them. Okay? We executed code paths just that we didn't anticipate and for which there was no off-the-shelf use case. We're blazing new ground here, all right? Again, functional validation of the data must be detailed and thorough. That's what XML Spy looks like when you open up one of these XML files, which are long and complex, okay, and it renders it in a way that you can look at the relationships pretty easily, whatnot. But you do look at the PDF output, which is, again, there's only one page that just shows purchase order, transfer order, sales order, all the little async UBEs that get called. And then over on the right-hand side, it said complete without errors, complete without errors. Whoops. The supplier package, UBE data selection did not select any data. You know, another one down there, error occurred during processing. So this is how, even though a UBE may end in a D or a done status, you know, even though there might not be bits and bytes all over the floor from the thing blowing up, you still would have functional problems that would be first indicated just by looking at the PDF, so you'll always want to look at that as well. Finally, observations here. What we have, to use another analogy, putting Humpty Dumpty back together again, it's like a many-body physics problem. Anybody have a clue about what many-body physics is? Gravitational influence of one body on another is complex enough, but as soon as you add a third, the equations just get immensely more complex, let alone when you have more than three. I mean, it's almost impossible, okay, to calculate all these mutual interactions. The only way you can figure it out, really, is observationally. And that's what you've got here. You've got a many-body physics with all of these tables, you know, that we're trying to statically analyze and predict how this thing is going to run, right? Well, the GOP code is an integration of Nummetrics under J.D. Edwards. Nummetrics was obtained via an acquisition, wasn't as well understood by our people here. We had only ever done happy path testing, not true real-life testing. And again, we didn't have precise and rigorous seed records the first time. Again, it's a demonstration of pristine versus real-life environments. And beta testing is something that can shake out these issues. Okay, we get to that in a sec. So if you look at the schedules we wrote out, and I've always said all project plans for software projects are lies anyway, because you're going to be wrong. It's not like building a house or building a space shuttle, where you've got a set number of tasks you're going to do. You've got a range of time you know those tasks are going to take. You can even factor in snow and rain and whatnot. You know, and it makes sense. But for software, the more detail you put in, the more of a lie the plan becomes to be. Because what we had estimated as being a scale of a couple of weeks really ended up being measured in months, not weeks, okay? The time involved to generate, the real data for a large project like this cannot be understated. Now, if you haven't figured it out by now, the building of data is a project in and of itself, okay? That's what this whole session is about. So in other words, we haven't even addressed the execution of the project for which the data set was intended. Maybe that'll be another session at some point in the future to get what we actually got out of that, okay? But already it's just such a ponderous thing that data building in and of itself is something you have to do, and it does help you understand what's going on before you get into analysis. So again, they have usefulness and relevance for other efforts, the methodology, the scripts. So we've got takeaways from this that go beyond just this project, okay? The methodology, the learning curve here are going to shorten this effort for other projects, all right? Now, what I promised before, what about door number 3 of creating the data? I mentioned that, and I mentioned a phrase called beta testing. Well, the fact is, this type of a project really is best suited to a beta testing effort with a willing customer. Reason being, the real environment and all the complexity, all the data relationships is already there. It is all in place. Okay, the bananas are already getting from Central America to Safeway. Okay, you just have to examine the process. You don't have to create that from scratch already. I mean, whereas in our environment, many of the required tables had no data, even in the most robust databases, because this is a very specific, need. And our databases, even the day in the life and our best test databases are meant to be as generic as possible to support, as many types of apps as possible. Okay, they're a compromise. Okay, we didn't have C data and tables like bill of materials and routing. Some of the C data, was on another machine used for testing. All kinds of problems. But this data would exist just in the normal course of running business in an actual live database. The normal course of getting those bananas, to the supermarket. The workers are all going to have shoes. The boats are all going to have fuel in them. All right, etc. Don't need to generate data. You can shake out problems quicker. And it's easier than trying to orchestrate, those bananas from Central America to Denver, okay? Now, I put the post-it note to use that whenever possible to avoid building out the ERP infrastructure. Now, again, the devil's in the details here as well, right? Except this time they're legal details and legal devils, if you will. We used to do this, it seems, more commonly when we were J.D. Edwards. Still then, it took a lot of signatures, a lot of agreements before we got to the point where we could do that. That's if we're bringing an environment here, but if you're using the environment at the customer site, it becomes a whole lot easier. There's fewer pieces of paper to sign other than just, okay, here, take this version in your test environment. It might break, it might spit bits all over the place, but the point is you understand we're testing. You understand that you, as a representative customer that would consume this type of data and run this type of project, are going to be helping us, and your takeaway is, based on whatever the salespeople work out, gee, you get this package for free or whatever. Don't know how those things work. Don't quote me on that. But so to do it on site, in a customer's test environment, it just eliminates this entire step, everything we've talked about for the last 40 minutes, okay? Like I said before, we called it a beta testing type effort. I think J.D. Edwards used to call them conference room pilots back in the old days, But again, you don't even need special hardware. Use their hardware, their environments, and just install this like you would any other ESU. And that some kind of an arrangement like that probably is better if you are concerned about time frames involved, all right? So a summary of all those little post-its. We mentioned 2 methods of creating data for performance projects. Use JD Edwards apps plus load testing or SQL scripts. Be sure to unit test data. Saves a lot of time up front. Number 3, an open heart surgeon's knowledge level of business functionality is needed to work out these type of problems myself, I don't know what I don't know about a lot of these things. In the best of scenarios, you're probably going to need several iterations to work on all the problems. Detailed data building efforts will flush out functional QA problems, guaranteed, if your blazing ground is new as this. Functional validation of the data has got to be detailed and thorough, okay, to make sure there's no errors in relationships deep in the data set. And finally, you know, use customer site beta testing whenever possible to avoid building out an entire ERP database infrastructure from scratch. Okay, this type of project is just, you know, tailor-made, is just a textbook example of the type of product for which that is really the best way of doing things. Finally, I always finish with first principles. Performance is not about, gee, give me a top 10 list, gee, give me this document and performance tips. It's all about understanding that performance is about where is the time being spent, okay, and everything else flows from that. Okay, that's all of the prepared canned material we've got. Is there any questions, comments, anything of that nature? Don't know if there was chat, I suppose. Would I have seen chat?
Yeah, I don't see any on the chat.
All right. So that means everybody's sufficiently intimidated enough by this, or sufficiently bored or falling asleep. I didn't hear any snoring, so everybody must have muted their phone okay.
Well, or I did.
Or yeah, you hit the global mute. Okay, well you can certainly send emails, either me or Clayton, you know, if there's anything else that comes up, anything else you think about this, but again, that is details of the ugliness of a data building exercise.
Okay. Thanks a lot, Chris. And just to, I know data building is really important, and that's one of the reasons that we're actually working on providing the DSS data, which is significantly larger data set, a little more realistic. So we'll have we'll try to have a little more information on the DSS data as it's available at the J.D. Edwards Summit. So hope to see everybody there. And if you are planning on coming, be sure and take a look at it and look us up and stop by and say hi. Okay, thanks, Chris, and thanks everybody for attending. And we'll come back at you next month.
Bye-bye now.